Hello and welcome back. So, still on structural analysis, we'll be looking at yield line analysis. And for today, we'll be looking at analysis of a frame. So we have a problem here. The question says the members of a steel portal frame have the relative plastic moment shown in the figure below. Calculate the required value of MP, which is plastic moment, for the ultimate loads shown. Okay, now this is our given diagram. So we are asked to determine the plastic moment. Now, when we want to carry out yield analysis on a frame, what is the first thing we need to know? The first thing we should know is that our first task is simply to sum our external work and our internal work. Okay, that's the first thing we should know. So, a very basic concept using the principle of visual work is that the summation of our external work done, okay, external work done is equal to the summation of our internal work done. Okay, now this is the first thing we should know. How do we get our external work done? External work done is simply the load times the deflection. So we should all know that external work done, okay, external work done at any point is simply equal to what? The load times the deflection. Okay? How do we determine our internal work done? Internal work done is simply equal to our plastic moment MP times our slope or rotation theta. Now this is what we should know. Okay, before we carry out our analysis, before we check for our different mechanisms, the first thing we need to check for our degree of indeterminacy. Okay, so our degree of indeterminacy, ID, so this is where our solution starts. This is just to note what this means. So according to the principle of visual work, external work done is equal to internal work done, and our external work done is simply load times deflection, and our internal work done is simply what? Our plastic moment times our slope. Now, our solution starts here. So our degree of indeterminacy for a frame is given as 3m plus r minus 3n, where m is the number of members, r is the number of reactions, and n is the number of joints. So we have our indeterminacy to be equal to, how many members do we have? We have 1, 2, and 3. So this is equal to 3 times 3 plus how many reactions do we have? Remember, this is a what? A fixed support. Hence, we have what? 3 reactions. We have a vertical reaction, a horizontal reaction, and a moment. So we have 3 reactions at this point. We have 3 reactions at this point. Hence, we have what? 6 reactions minus 3 times number of joints. How many joints do we have? 1, 2, 3, 4. Our indeterminacy to be equal to 3 times number of members 3 plus our reaction 6 minus 3 times number of joints 4. So we have this to be equal to 9 plus 6 minus 12. So we have this 9 plus 6, 15 minus 12 is what? 3. So our degree of indeterminacy is what? Equal to is equal to 3. Now, after getting our degree of indeterminacy, the next thing we get is number of plastic hinges. So number of plastic hinges is simply equal to degree of indeterminacy plus 1. And that's equal to what? 3 plus 1, which is equal to what? 4. So for this frame, the maximum number of plastic hinge is what? 4. So after getting the number of our plastic hinge, the first thing we do is to draw our beam mechanism. Okay? So for our beam mechanism, we are considering our focus is on the beam, the failure occurring on the beam. So we have 30 kilonewton. We have 30 kilonewton. Now, we know due to this load, there will be what? A deflection at this point. There will be a deflection at this point. Now, in drawing our beam mechanism, we simply ensure that we find our deflections at the point where we have loads. Okay? So we are going to have this. Okay? We add this distance to this distance. Let's call it delta 1. Okay? This deflection. And call this deflection what? Delta 2. Okay? Now, let's call this angle theta. Okay? So let's call this theta. And let's call this angle beta. All right. Now, hence, this is going to be what? The addition of these angles. Now, remember, we want to get our external work done and our internal work done. What is external work done? It is simply what? Load times deflection. How do we get the external work done on this beam mechanism? It's simply the several loads multiplied by what? The deflection. Hence, external work done is simply what? 30 kilonewton multiplied by this deflection plus 30 kilonewton multiplied by what? This deflection. Our task now becomes to find the expression for this deflection. Now, let's consider this triangle. Okay? So, if we consider this triangle, we have this point to be what? Our deflection. We have this to be our what? Theta. We know the distance from this point to this point. Okay? This is what? 3 meters, 3 meters, 3 meters. So this point is 3 meters. Now, if we take tan theta, we know that tan is equal to what? Opposite over adjacent. This is the opposite, and this is the what? Adjacent. So tan theta is going to be equal to what? Deflection, which is our opposite, over our adjacent, which is what? 3. But because this angle is so small, hence tan theta is equal to what? Theta. So we have, okay, tan theta equal to tan theta is equal to theta, which is equal to what? Opposite over adjacent. So this deflection, which is deflection 1 over 3. Hence, from this point, making deflection subject of a formula, we simply multiply. So if we cross multiply, deflection is going to be what? 3 theta. So we have our deflection to be equal to what? Deflection 1 to be equal to 3 theta. We have gotten the value for this deflection, right? Now let's get the value for this. Are we following? Is anybody confused? Our first assignment is to get degree of indeterminacy, because from degree of indeterminacy we get number of plastic hinges. Then we come to beam mechanism. noting that we want to get our external work done and internal work done. Okay, so after getting our theta 1, now the next thing we consider to get, after getting our first deflection, to get this second deflection, let's first of all get this angle. Okay, we know that theta 1, okay, our theta is equal to what? This over this. Now let's get from this point. If we consider that triangle, okay, we consider this triangle, all right, which is this triangle. We have the distance from this point to this point to be what? 6 meters. Okay? We know this point, which is this point, which is our what? Delta 1. And delta 1 is equal to what? 3 theta. Hence, this point to this point is 3 theta. Right? We have this angle to be what? Beta. Now, if we take tan of beta to tan beta, this is directly opposite this angle. Remember that tan is opposite over adjacent. So it's going to be the opposite over the adjacent. So tan beta is going to be equal to what? 3 theta, which is our opposite, which is our deflection 1, all over 6. But because this angle is going to be so small, we can take tan beta to be equal to what? Beta. So tan beta is equal to beta, and that's equal to what? 3 theta all over 6. Alright? So from this point, we have, if we cross multiply this, okay, so we have what? 3 theta to be equal to what? 6 beta. Alright? So if we make beta subject of the formula, we simply divide both sides by what? 6. Okay? So this takes away this. So we have beta to be equal to what? 3 theta all over 6. 3 over 6 gives us what? 1 over 2, which is the same thing as 0.5. So this is equal to what? 0.5 theta. Hence, our beta is what? 0.5 theta. Okay, now we have gotten the value for our beta. Remember, for us to get external work done, we need this deflection. So how do we get this deflection? So we simply consider this portion of the triangle. Alright? So if you consider this portion, which is this portion, we have this to be beta, and then we have this to be our delta subscript 2, and then we have this to be 3 meters. Alright, so if we take tan of beta, which is equal to opposite, which is this, over what? Adjacent, which is 3 meters. So also, as we know earlier, because this angle is going to be so small, tan beta can be taken as what? Beta. And what is beta? Beta is 0.5. So we have this tan beta, which is equal to beta, and we know that beta is equal to what? 0.5. Okay, let's go. So this is equal to beta, and beta is equal to this over 3. So at this point, if we cross multiply to make this subject of the formula, we are going to have this to be equal to what? 3 beta. So this is equal to what? 3. What is beta? 0.5. So 3 times 0.5 theta. Hence, our second deflection is equal to what? 3 times 0.5 is what? 1.5. 1.5 theta. Hence, we have this to be what? 3 theta, and this to be equal to what? 1.5 theta. Now, after getting this, let's, okay, now, before we sum our external work, let's take note. We are given the plastic moment for our beam to be what? 2 times our plastic moment. And for our stanchions to be what? Just MP. But for our beam to be 2 MP. So, for this beam, okay, we are going to have 3 plastic hinges. Okay, so this is going to be MP. This point is going to be this point is going to be 2 MP. This point is going to be MP. So we have 3 plastic hinges for our beam. Now let's sum our external work. Summation of external work done. Okay. Remember, our external work done is what? Load times deflection. So it's going to be equal to what? 30 times what? Delta 1, right? Plus 30 times delta 2. And this is going to be equal to what? 30 times what are delta 1? 3 theta, right? Plus 30 times delta 2, 1.5 theta. All right? So 30 times 3, so this is going to be 90 theta plus, so 30 times 1.5 gives us 45 theta. Now, this is the summation of our external work done. Summation of internal work done, okay, is simply equal to, remember, summation of our internal work done is simply what? Our plastic moment times what? Theta, the angle. Okay, so we have how many plastic moments? We have 3. So it's going to be this times this angle, this times this angle, this times this angle, plus this times this angle, plus this times this angle. All right. So summation of internal work done is simply equal to what? MP theta, which is MP times theta, plus what? We also have MP beta, plus MP beta, plus what? 2 MP, okay? Let me write this downwards. Plus 2 MP into what? Theta plus beta, which is the summation of these angles, okay? Summation of 2 interior angles in a triangle is equal to what? The exterior angle. So this is equal to MP theta plus, we are going to express beta in terms of theta. So plus MP, what is our beta in terms of theta? Okay? Times what's our beta in terms of theta? 0. So we have MP theta plus MP times expressing, so beta is simply equal to 0.5 theta, which is half of it, okay? Plus our 2 MP into theta plus 0.5 theta. So we have this to be equal to MP theta plus 0.5 MP theta. So this is MP times 0.5 theta. So bringing the number forward, so 0.5 MP theta plus 2 MP times theta is what? 2 MP theta plus 2 MP times 0.5 theta is what? Is what? 1 MP theta, which is the same thing as MP theta. Hence, summation of our internal work done is simply what? MP theta. So all our expressions are now in what? MP theta. Okay? So we have this place to be 1. This is half. So this is 1.5. Okay? Plus 2. This is 3.5. Plus this is what? 4.5. So we have this to be equal to what? 4.5 MP theta. All right. So having gotten our external work done and our what? Internal work done. Our next task is to what? Equate our external work done to our internal work done. So according to using visual work method, our external work done, okay, is equal to summation of our external work done. Summation of our external work done is equal to summation of our internal work done. So what's our external work done? Our external work done is what? 90 theta plus 45 theta. So 90 plus 45 is equal to what? 135 theta is equal to our internal work done 4.5 theta. 4.5 MP theta. Okay. So from this point, remember we are asked to get our what? Our plastic moment. Okay? So from this point to make our plastic moment subject of the formula, we simply divide both sides by what? 4.5 what? Theta. So if we divide this side by what? 4.5 theta. So this takes away this. Hence, our MP plastic moment for our beam mechanism is equal to what? 135 all over, remember this takes away this, all over what? 4.5. And that's equal to what? That's equal to 30 kilonewton meters. Now we are done for our beam mechanism. Our next task is to repeat this process for our sway mechanism and for our combined mechanism. Okay, so we are done with our beam mechanism. The next mechanism we have to consider is our sway mechanism. Okay, now we remember for when we were considering our beam mechanism, our focus was the failure occurring on what? The beam. Now we had this structure. If a load is applied at this point, what will happen? The structure will tend to move in this direction. It will tend to sway, right? If this part sways, this part will also what? Sway to this axis. Okay? Hence, this was the initial position of, right? This was the starting position. But as a result of the application of this load, this beam, this section of our frame moves to this point. Hence, we have what? A deflection at this point, which is a movement. Okay? Right. Still using the concept as we established earlier, our external work done is simply equal to what? Our force times our load. Now, our first task here to get our external work done, we can see that we have only what? How many load on the sway axis? We have just one load. So it will be what? 25 kilonewton times what? This displacement. How do we get this displacement? Okay, now we want to determine the magnitude of, or the displacement, the magnitude of this displacement. So we have this triangle over here. Okay, so we have this. So to get our displacement, we simply take a tan of this. So tan theta, knowing that this portion is opposite this angle, this is our hypotenuse and these are the adjacent points to this angle. So tan theta is equal to what? Opposite over adjacent, in which our opposite is our deflection and our adjacent is what? 4 meters. Because this angle is small, we can take tan theta to be theta. Hence, tan theta is equal to what? Deflection over 4. Cross multiplying, we have our deflection to be what? 4 theta. Now, before we go on to some external work done, we remember that the number of plastic hinges is what? Maximum number of plastic hinges for this structure is what? 4. Okay? So on this structure, we are going to have a plastic hinge at this point, a plastic hinge at this point, a plastic hinge at this point, and at this point. MP, at this point, we are going to have MP. At this point, we are going to have what? MP. Also at this point, we are going to have MP. So we are going to have what? 4 plastic moments. All right. So summation of external work done is simply equal to what? Force times load. How many forces do we have on the sway mechanism? 1. So it's going to be equal to what? 25 times the deflection. Knowing that our deflection is 4 theta, this is going to be equal to what? 25 times 4 theta. And that's going to be equal to what? 100 theta. All right. The next thing, summation of internal work done is equal to what? Our various plastic moments multiplied by our what? Theta. So how many plastic moments do we have? 1, 2, 3, 4. So it's going to be what? MP theta plus MP theta plus MP theta plus MP theta. And this is going to be equal to what? 4 MP theta. All right. After summing our internal work done, now note for this analysis, we are making use of what? The visual work principle. Hence, summation of external work done is equal to what? Summation of internal work done. All right. So what's our external work done? Our external work done is what? 100 theta. And that's equal to summation of our internal work done, which is what? 4 MP theta. All right. So at this point, making plastic moments MP subject of the formula, we simply have what? MP to be equal to what? 100 all over what? So this takes out this. So this is equal to 100 over what? 4. Right? So we have this to be what? 25 kilonewton meters. All right. Now, after getting our beam mechanism and our sway mechanism, the final mechanism we consider before we determine the expression for the value of our plastic moment is the combined mechanism. Okay, so for our combined mechanism, we simply draw the sway mechanism and our beam mechanism at one place. Okay, so we have this. Okay, so we have our sway mechanism. So for our sway mechanism, we are going to have our plastic hinge at this point, this point, this point, and this point. Remember, our maximum plastic hinge for this system is what? 4. Okay? So at this point, we have what? MP. At this point, we have what? 2 MP. At this point, we have MP. And at this point also, we have MP. Okay, so at this point, okay, so we know this deflection to be what? 4 theta. We know our deflection at this point to be what? 3 theta, right? 3 theta. Okay, this is our beta. Our deflection at this point is what? 1.5 theta. So, on the combined mechanism, summation of external work done, okay? So, summation of external work done is simply equal to what? All the loads multiplied by the various what? Deflections. Alright? So we have this to be equal to what? 25 multiplied by the deflection, and that's what? 4 theta plus 30 times what? 3 theta plus 30 times what? Plus 30 times 1.5 theta. Okay? Hence, this is equal to what? 25 times 4 is 100 theta plus 30 times 3, 90 theta plus 30 times 1.5, 45 theta. So 100 plus 90, 190 plus 45, 235. So this is equal to what? 235 theta. Alright, so our next task is summation of what? Internal work done. And that's equal to what? Our plastic moment multiplied by what? The angle. So let's start from this point. We have MP multiplied by what? Theta. So we have this to be what? MP theta plus, at this point we also have what? MP theta. At this point we have what? MP beta. So plus MP theta plus what? MP beta plus 2MP theta plus beta. Okay, so this is plus 2MP theta plus beta. What is our beta? Our beta is simply 0.5 theta. And this is equal to MP theta plus MP theta plus MP beta, and this is what? 0.5 theta. Hence we have plus what? 0.5 MP theta plus 2 MP theta, 2 MP theta, okay, plus, now this is beta. Beta is what? 0.5. 2 times 0.5 is what? 1. Okay? And that is MP theta. Alright. So we have all expressed in MP theta. So this is what? 1 plus 1, 2, plus 0.5, 2.5, plus 2, 4.5, plus 1, 5.5. Hence we have this to be equal to what? 5.5 MP theta. Alright. Okay? So still on the principle of virtual work, summation of our external work done is equal to summation of our internal work done. So summation of external work done is equal to summation of internal work done. And our external work done is what? 235 theta is equal to what? 5.5 MP theta. So at this point, we make our MP, plastic moment, subject of the formula. So we have, so at this point, this theta takes out this theta, within it. Okay, so from this point, making MP subject of the formula, we have MP, our plastic moment to be equal to what? 235 divided by 5.5. And that is equal to what? 42.73 kilonewton meters. Now we compare the values of our plastic moment for our sway mechanism, beam mechanism, and our combined mechanism. Which of them do we have higher plastic moment value? It's obviously for our sway mechanism. So this is the plastic moment for our structure. It is always, the plastic moment for the structure is always the plastic moment of the combined mechanism.